Hello, this is Unit 4, and on Day 2 we're going to continue to apply the distributive property. Today we're going to review what we did yesterday, and we're going to extend it by inserting a variable into our expression. So let's start by reviewing what distribute means. In our video they talked about a newspaper boy who distributes paper to each house on his route. So he distributes a newspaper to each house on his route. Here we have another example. This is a car distributor. A distributor in a car is very much like a spinner. It's a precise spinner, and as it spins, it distributes the sparks to the individual spark plugs at exactly the right time. They have to go in a specific order and happen at a specific time for the car to work properly. Here's another example. Here's a dealer who's distributing cards. And a fourth example, right now we've kind of got Halloween on the mind. Here's a home, and it looks like the mom is distributing candy to the trick-or-treaters. So we talked about how the order of operations and the distributive property get to the same result. So there's two different ways to solve equations. So here we have the order of operations, and we have 4 rows, and we're multiplying by 3 columns and 4 columns. So we added our 3 columns and our 4 columns to get our 7 columns. So we're multiplying 4 rows by 7 columns, so we get 28 total. With the distributive property, we are distributing the 4 to the 3 and distributing the 4 to the 4. So in this particular situation, we still have our 4 rows and our 3 columns, and together they make 12. And then we have our 4 rows and our 4 columns, and they make 16. So we can add the 12 and the 16, and we'll get 28 for our total. We get the same answer. We just used order of operations in this example and distributive property in this example. Remember, the distributive property works for addition and for its inverse operation, which is subtraction. So let's look at an example. Here we have 9 times the sum of t and 6. So we're starting first by distributing the 9 to the t, so that would be 9 times t. Then we're distributing the 9 to the 6, 9 times 6. Now because we've distributed, we can get rid of our grouping symbols or our parentheses, because we know we have to multiply before we add. So 9 times t would be 9t, and 9 times 6 would be 54. So this is our expression in simplified terms. We can't go any more simplified because they're unlike terms. We have 9t here, and we have a constant here. So that's our answer. Here's another example. We have negative 7c minus 9 times the sum of 4 and 6c. Now, to do this one, I'm worried I'm going to lose this negative sign, so I'm going to add the opposite. I'm going to take negative 7c, and I'm going to add negative 9 times the quantity, or the sum, of 4 plus 6c. So that's what this looks like. Now I'm not going to lose that minus sign. So I'm going to have negative 7c, and I'm going to distribute the negative 9 to the 4, and I'm going to distribute the negative 9 to the 6c. So now I've distributed, and I can just go ahead and multiply. I have negative 7c plus a negative 36 plus a negative 54c. So I can combine my like terms. I have a negative 7c and a negative 54c, so I have a negative 61c minus 36, or negative 61c plus a negative 36. Either one is correct. So let's have you try a few problems. We have negative 6 times the sum of 3n and 6. Go ahead and try that one. Okay, next we have 10 minus 2 times the sum of 8 and 2a. Now again, we have a subtraction symbol here, and we don't want to lose that subtraction symbol, so we could rewrite it as an addition equation. So we could write 10 plus a negative 2 times the sum of 8 and 2a. So this might be more helpful for you to solve. And last, let's look at this problem. You have negative 3 times the difference of 5a and 3 added to 4a. Go ahead and try that. Before you finish, tell me something that you learned or were reminded of and a question that you have. Make sure that you answer both sentence starters.